Guys, in this video we're going to be looking at two forces in 3-dimension. So in previous videos we've looked at forces in 2-dimension, so what we're doing differently here is adding our z-axis over here. We have our x-axis which runs this way and our y-axis which runs this way. So let's get started. Let's start by labeling our forces. We have one force vector which is over here. It has a magnitude of 400 pounds and this triangle associated with it. We don't have an angle, so this triangle is going to be handy. So I'm going to label this force 1 as F1. We have a second force over here, force vector, and it has a magnitude of 500 pounds and two angles associated with it. So I'm going to label this F2. So what we're trying to do for this problem is find the resultant, the magnitude. So the magnitude and direction of the resultant. Okay, so to start off, let's look at force 1. When you look at force 1, we see that it's really two-dimensional because it lies on one plane. It lies on the YZ plane and not the X plane. How do I know that? That's because the 4 is parallel to the y-axis and the 3 line is parallel to the z-axis. So going from there, what I can do is I can set my components up for F1. So F1 has the components F1x, F1y, F1z. We know that F1 does not exist in the x plane, so based on that, what I can do is say that my F1x is 0. For my F1y and F1z, however, I'm going to have to use this triangle over here. Okay. So going from there, I know that this angle right over here inside equals this angle over here. So if I use my tangent function, which is opposite over adjacent, I'm going to get the tan inverse of 3, which is opposite from the angle, over 4, which is adjacent from the angle, is going to result in 36.87 degrees. Okay, so this is the angle associated with F1 angle. So from there, I can get my F1y, which is equal to the magnitude of F1 times, because y this time is in the adjacent side, I'm going to have to use a cosine function. So cosine of 36.87. So F1 again equals 400. So F1y equals 400 times cosine of 36.87. So if I plug this into my calculator, so grab my calculator and I'm going to plug in 400 times cosine of 36.87, I'm going to get that F1y equals 319 actually I'm going to round up to 320 pounds because it goes as in 0.9995. So I'm just going to round up to 320 pounds. Now for F1z, I'm going to have to take the magnitude of F1 and multiply it by the sine of 36.87 because we're looking for the opposite side from the angle. So that would be sine. So plugging into our formula, we're going to get that F1, which is 400 from here, times the sine of 36.87 equals So let's plug in for sine, and we get 240 pounds. Okay, so going back up here, let's plug this into these two numbers into our expression. So we're going to have 320 pounds for the y component and 240 for the z component, and this is in pounds. Okay, so here is our F1 component. And now let's move on to our F2 component. So F2 has the components F2x, comma, F2y, comma, F2z. So looking at this diagram over here, we see that this vector is in all three dimensions. So it's in the x-plane, and it is in the y, but it's also in the z, unlike the first force. So to simplify this, what we can do is we're given this triangle. So this line is in the xy plane. And then moving it down, this is what creates our z-plane. So to get our z value, what we can do is try to obtain this, this vertical line over here. We know that to solve for that vertical line, I'm going to have to take the magnitude. So again, we're solving for F2z over here. So F2z equals the magnitude of F2 times, so when we're looking at this triangle, we have to identify that we're looking at this angle, not this angle, but the 45 degrees that is associated with this pink triangle. So based on that, we're going to have sine, because this line is opposite from the angle, so sine of 45. So plugging this in, I'm going to get F2z equals 500 pounds times sine 45, and that's going to give me F2z equals, so if I plug this in, 500 times sine 45, I'm going to get 353.55 pounds. So this is for my z. So I'm going to have some space, and then I'm going to have 353.55. Now to get my x and y values, I have to get it in the xy plane. To get to the xy plane, I'm going to have to use part of this triangle. So I want to get to this line over here. Let's use a different color. I want to get to this line over here. And that's pretty easy to do because I have this angle right over here, this 45 degrees. And using that and the magnitude, which is this line over here, this is 500, this is 45, and all I need to do is find the adjacent side. And to use the adjacent side, I'm going to have to use the cosine function. So I'm going to do I'm going to call this line over here to the xy plane, I'm going to call that F2 prime. So F2 prime equals F2 times, because we're dealing with F2, times the adjacent side, so that's going to be cosine of 45. And plugging this in, I'm going to get F2 prime equals 500 times cosine of 45. So 500 cosine 45 is going to give me the same thing, so that's 353.55. Okay, so from there, what we can do is get our x and y values. So going from here, F2x is going to equal our F2 prime, and I can draw another triangle here, which is going to look like this, this, and this, where this line over here represents the y, and this line over here represents the x, and there's a 90-degree angle over here. This is our hypotenuse, this line F2 prime that we just calculated. So to get to our F2x value, we are given this 25-degree angle, and we can use that by saying that we want the adjacent side. So that would be cosine. So F2 prime cosine of 25 right here. So F2 prime cosine 25. So F2x equals 353.55 times the cosine of 25. And that's going to give me F2x, which equals 320.43 pounds. Similarly for F2y, I'm going to do F2y equals F2 prime. And now we want the opposite side, so that's the sine function, so sine of 25. So F2y equals the magnitude of F2 prime, so that's 353.55 times sine 25. And that's going to give me F2y, which equals sine 25. That's going to give me 9.42 pounds. Now, when we put this back into our equation, it's important to note the where the vector is. So for F2x, we have a magnitude of 320.43 pounds. And it is pointing in the positive x direction. So for F2, we're going to get my x value is going to be 320.43, comma, my y is also in the positive direction. So it is going to be positive 149.42. And my z is actually in the negative z direction. It's pointing downwards. So it's going to be negative, really it's going to be negative 353.55 pounds. Okay? So now that we have our F1 and F2 components, we can get our resultant. So to get a resultant, what we're going to have to do is add the components. So resultant, which is FR, equals F1 plus F2. And we can really expand this to equal F1x plus F2x, comma F1y plus F2y, comma F1z plus F2z. Okay, so we know that F1x is 0. So I'm going to come down and plug this in. So 0 plus F2x, which is 320.43, comma, F1y going up, it is 320 pounds. So 320 plus F2y, which is 149.42, and F1z, which is 240 pounds, which I got from up here. So 240. And then plus negative 353.55 from our F2z. So I'm just going to write minus 353.55. And I'm going to put our units of pounds, and this is what FR equals. So solving this, I'm going to get FR equals 320.43 for my x component. And then for my y component, I'm going to get 320 plus 149.42, which is 469.42. For my z component, I'm going to do 240 minus 353.55, which is going to give me negative 113.55. So now we have our x, y, and z components for our resultant force. To get the magnitude of all we're going to have to do is use a distance formula. So what we're going to do is write down FR with these absolute value signs, which really means you're trying to find the magnitude. And we're going to do x squared plus y squared plus z squared. And then square root that. But what we're really trying to do is x minus 0 squared plus y minus 0 squared plus z minus 0 squared. And that really matches over here. It just the zeros just get redundant over time, but they are a good habit to write down in steps. Okay, so going from there, I know that the magnitude of FR equals my x value, which is 320.43, 20.43 squared plus 469.42 squared plus negative 113.55 squared. And taking the square root of that, so I'm going to plug this into my calculator. So square root of 320.43 squared plus 469.42 squared plus negative 113.55 squared is going to give me 579.59 pounds. And this is the magnitude for my resultant vector. Now for the angle, what we're going to have to do is do alpha, beta, and gamma. So we're going to have three angles. So alpha, beta, and gamma. And we're going to take the cosine inverse of FRX, so the x value of our magnitude or for resultant force, and over our resultant force. And then for beta, we're going to do the cosine inverse of the y component over the magnitude. And then for gamma, we're going to do the cosine inverse of this z component over the magnitude. Doing so, we're going to get cosine inverse of 320, which is right over here, 0.43, over the magnitude, which we just calculated to be 579.59. For this one, it's going to be cosine inverse of 469.42 over the magnitude, which is again 579.59. And lastly, for gamma, we're going to have cosine inverse of the z component, which is negative 113.55 over 579.59. And when we calculate this, we're going to get, so the cosine inverse of 320.43 over 579.59 gives us 56.44 degrees. For beta, we're going to get the cosine inverse of 469.42 over 579.59 is going to give us 35.91 degrees. And for gamma, lastly, we're going to get that the inverse of negative 113, or the cosine inverse of negative 113.55 over 579.59 gives us 101.29, or we can round it up to 3 degrees. And that makes sense because what we're trying to say is that this resultant force is downwards on the z-axis. So it kind of points like this way. Okay, so those are our 3 angles, and I'm going to use this color actually. So that's our answer. So we have our direction, which is in these 3 angles, and our magnitude, which is 579.59 pounds. Thanks for watching.